Well, right now, a warning for Southern California about the increased risk.
Beneath the rolling waves and misty peaks of America's west coast, something vast and ancient is stirring. In a span of weeks, from Alaska's frozen shores to California's rugged boundaries, "21 volcanoes have flared to life, roots straining, their flanks trembling with new energy."
Now, a powerful eruption caught on camera.
For decades, the Pacific Ring of Fire loomed as a distant threat, its fire-breathing giants mostly stirring on the far rim of a restless ocean. But now, attention has shifted homeward, to the depths and wild mountains lying just off America's edge. On May 2nd, 2025, volcanologists around the world blinked at their screens. 47 volcanoes erupting worldwide, a substantial portion clustered along the volatile arc facing the United States. But it wasn't remote islands or unfamiliar peaks that captured their focus. It was home. The entire western flank of North America pulsed with earthquakes, swelled with magma, rumbled with frequencies not seen in decades. One name kept surfacing: Axial Seamount, a colossal undersea volcano 300 miles off Oregon's coast. Its warnings rising in tempo, its flanks lifting in a silent promise of eruption before year's end. The Pacific is flexing its power. From California to Washington, its hidden mountains are stirring, each one a force of nature set in motion long before cities or forests existed. The puzzle is only beginning to reveal itself. 21, a number echoing across networks and satellites deep into the oceanic crust. But what does it all mean? Is it simply nature's cycle or the harbinger of something far greater? An event poised to reshape the land and legacy of America's West. Chapter 1. The Inferno Awakens. Nowhere on Earth is more alive beneath its skin than the Pacific Rim. Yet even with its centuries of fury, North America's western border hasn't seen such a sharp uptick in volcanic activation in recent history. The numbers alone stand out, from the solitary cone of Mount Shasta to the submarine heights of Axial Seamount. Signals buzz along the coast, linking volcanic activity across a vast distance. The signs were built gradually. For weeks, subtle jitters danced under the feet of Portlanders and Seattleites. Slight, almost imperceptible shakes, as if the ground itself was quietly inhaling. Scientists with the USGS Volcanic Hazards Program observed unusual patterns. Clusters of small quakes, rhythmic and persistent, pacing along fault lines from southern Alaska to northern California. These pulses weren't random, moving in discernible waves, suggesting coupling between volcanic systems. Then, visible warnings appeared. Plumes of steam, once a trickle, began to spiral skyward from Mount Rainier's vents. Near Lassen Peak, remote seismometers picked up a sudden, low-frequency roar, an unmistakable sign of magma shifting through solid rock. Hot springs across the Cascades grew warmer. Riverbeds, typically tied to the rhythm of the seasons, now ran cloudy and hot as geothermal flows bled to the surface. But nothing sent more chills through the scientific community than the awakening of Axial Seamount. This volcano, hidden in the ocean's darkness, is more than just another peak. It is an indicator, a key site along the Juan de Fuca Ridge where two tectonic plates are pulling apart. Since early spring, its slopes have risen by centimeters, edges shifting upward with a scale of deformation not seen since its 2015 eruption. Then came the earthquakes, a swarm echoing through the abyssal plain. At first, the signals were faint. By late April, their pace quickened, double tremors arriving in minutes, each stronger than the last. Two larger quakes rattled the western flank, sending seismic waves up through the seabed, reaching detection instruments on land. 21 volcanoes are now classified as active by global agencies, a high not seen in recent generations. Alaska's Rainier issued plumes of ash, a reminder that the northern end of the chain remains restless. Some volcanoes that appear quiet may simply be recharging, holding their energy for a future day. Yet the most unsettling observations did not come from the Cascades or the Pacific seabed, but from deep beneath Yellowstone. The question hanging over every lab and monitoring station became impossible to ignore. Is this coincidence or coordination? Are we witnessing isolated volcanic restlessness or the early movement of a system awakening as one? The answers, scientists caution, are still being sought. Chapter 2: Beneath the Surface. The Hidden Titans. Beneath the forests, cities, and ocean lies a realm more ancient than any present-day landscape. At the plate boundary, the Pacific Plate plunges below the continent, generating a chain of volcanoes running from the Aleutians down to Baja California. The Ring of Fire, a circle of seismic and volcanic activity, supports millions of lives above it. Here, the storied peaks of the Cascades hold court. Mount St. Helens, with its legendary 1980 eruption. Mount Rainier, crowned with glaciers, looming above Seattle. Crater Lake, whose tranquil surface conceals the caldera of an old violent blast. But these are simply the visible summits. For every exposed volcano, there are others beneath the surface, unknown, mostly unseen, now showing signs of activity. Axial Seamount dominates this hidden world. Towering over 7,000 feet above the seafloor, its massive caldera spans 3 by 5 miles, a gash in the crust. As 2025 advances, its bulk slowly rises, fissures oozing superheated water and minerals. The volcano's magma chamber expands, as if the Earth is holding its breath. Mirroring this, Alaska's Rainier, a glacier-clad summit, has stirred, spitting ash and steam, its chamber fracturing anew. Seismographs detect subtle rock falls inside, a hint of further unrest. Mount Shasta's roots have warmed, Lassen's fumaroles vent louder, and Mount Hood's sensors catch signs of slow-rising magma inching closer to the surface. Satellites tell the same story from above. InSAR images detect uplift, not just under single peaks, but in broad regions from southern Canada to central California. GPS stations track the slight but growing horizontal slips along the Cascades, each a symptom of rising underground tension. Even underwater, bursts of hydrothermal activity mark the spreading seafloor. New land is being created in the ocean darkness. Every vent and fissure a warning that the action is not slowing, it's accelerating. But the real revelation comes from deep tomography scans, 3D imaging of the Earth's interior. These scans reveal magma corridors, long serpentine highways of molten rock that extend for hundreds of miles beneath the crust. Once believed to be isolated pockets, these reservoirs now appear to be interconnected, allowing pressure to travel between them. This means that activity at Axial Seamount could influence Mount Rainier, that changes under Lassen could echo beneath Shasta, and that tremors in the Aleutians could send waves of stress rippling down the entire west coast.
In other words, the system is not made of separate volcanoes. It is one enormous body, alive, pressurized, and restless. What could trigger such an event? And are we equipped to understand these signals? For now, the answers remain buried, deep beneath the surface.
Chapter 3: The Pulse of the Ring, Patterns in Chaos. For outsiders, volcanic eruptions might seem chaotic, impossible to predict. But those who study the Earth find patterns beneath the surface. And in 2025, the patterns have come into sharp focus. The numbers were the first signal. 47 eruptions worldwide, with nearly half clustered on America's western edge. The famed volcanoes of the Pacific Ring of Fire appeared to awaken together. Scientists pored over seismic records, hunting for connections. It became clear, earthquake clusters weren't occurring in isolation. When Axial Seamount trembled, similar quakes appeared in the Cascades. When Rainier surged, distant sensors also captured tremors. It was as if deep Earth processes knitted North America's volcanic arc together.
The rhythm is distinct. As seafloor crust cracks, satellite gravity readings suggest mass moving upward. Magma inflating chambers not thought to be active for centuries. The synchronicity of these events is suggestive, if not yet fully explained. USGS and NOAA have issued updates stating, "We are witnessing coordinated increases in volcanic activity along the west coast." The implication? A regional driver may be at work, likely tied to plate tectonics, but debate remains. Some argue these are natural fluctuations, the result of long geological cycles, not necessarily evidence of a deep connection. But 21 volcanoes awakening is exceptional, and a sustained surge in regional energy cannot be dismissed outright. The deeper concern is the pattern unfolding beneath the surface. A pulse, a cyclical rise and fall of pressure, detectable not only in quakes but in geothermal output, gas emissions, ground deformation, and heat flux into shallow crust. This pulse has been recorded before, though rarely, and usually preceding clusters of eruptions. Researchers at the Cascades Volcano Observatory describe it as the breathing of the lithosphere, a steady build-up and release of strain, as if the continent itself is slowly flexing against the Pacific plate. Some models now suggest the entire western margin acts like a single, interconnected supersystem, where pressure changes at one volcano can subtly influence conditions hundreds of miles away. Not enough to trigger an eruption directly, but enough to prime the system, to make eruptions more likely, to shorten recharge times, to weaken the crust. The lingering question is not whether any one volcano will erupt. Some will. The question is whether eruptions will occur one at a time or together. A synchronized volcanic sequence is rare, but not unprecedented. And when it has happened before, it reshaped landscapes, climates, and history itself. So the question stands, unresolved and urgent. What does it mean when so many volcanoes trend upward at once? Is North America being reshaped from below? Or is this merely a signal, a warning of something still gathering strength? Chapter 4. America's Unseen Threat, the Sleeping Giants. As new eruption seize headlines, a quieter threat lies in the volcanoes that have not yet erupted, but exhibit clear signs of unrest. In North America, many volcanoes slumber for centuries between events, their scars visible, but their rhythms elusive. The dormant giants of the Cascades, Mount Baker, Glacier Peak, Mount Rainier, bear witness to ancient catastrophes. Past eruptions have transformed landscapes, dammed rivers, and coated valleys in ash. A peaceful mountain today can become a hazard tomorrow, often with only weeks of warning. Evidence of unrest is spreading. Mount Shasta's flanks show new cracks. Mount Hood releases increased volcanic gases. At Mount Rainier, clustered quakes hint at magma movement beneath its ice. At Lassen Peak, a sudden uptick in ground deformation and shifts in geothermal chemistry keep scientists on alert. Across Alaska, the line of fire persists. Volcanoes such as Veniaminoff, Shishaldin, and Pavlov erupt frequently, sending ash clouds into busy air routes. A threat not only to communities, but to aviation worldwide. Offshore, the invisible is becoming increasingly visible. Axial Seamount, monitored round the clock, registers uplift and earthquake swarms, clear signs that its magma chamber continues to inflate. Ocean bottom sensors, a rarity until recent years, now broadcast near real-time updates, giving an unprecedented look at undersea volcanoes. The pressing question: are these volcanoes acting in unison,
by coincidence? Or is a common trigger setting multiple systems into motion at once? What mechanism might explain such a pattern? The answers may require new knowledge from the very edge of geoscience. Chapter 5. The Undersea Wildcard, Axial Seamount's Looming Eruption. Axial Seamount now draws the world's focus, a giant hidden beneath the waves, perched at the boundary where tectonic plates split. It is the most active submarine volcano in the region, linked directly to the ongoing spreading of the Juan de Fuca Ridge. This year, the volcano's activity has sharply accelerated. Seismic swarms intensified, and inflation of the volcano's summit outpaced anything measured since 2015. A web of instruments, pressure sensors, thermal probes, submersibles, recorded these changes with extraordinary detail. Satellite data confirmed vertical uplift, and seismic traces captured long, low rumbles associated with rising magma. For the first time in history, researchers predict the volcano may erupt months in advance, an unprecedented leap in forecasting. While most volcanoes offer only days of warning, Axial's unique setting and intense monitoring make it a natural laboratory. Why does a submarine eruption matter? Underwater eruptions may not threaten coastal communities with lava, but they can trigger minor tsunamis and alter ocean chemistry. The creation of fresh seafloor by axial seamount is also an essential process in shaping the continent over millennia. After eruptions, hydrothermal vents arise, sustaining unique ecosystems in otherwise barren depths. More significantly, stress changes linked to the eruption may influence faults onshore. As magma moves and rocks crack, stress redistributes along plate boundaries. A large undersea eruption can, in theory, affect pressures further inland. While the exact risk remains under study, the potential exists for seismic impacts that reach as far as the Willamette Valley or Puget Sound. Axial Seamount's approach to eruption is both a triumph and a test for volcanology. Never before have so many signals converged to support such a forecast, and never has there been so much at stake in understanding what a submarine volcano can tell us about the entire margin. Chapter 6. Forecasting the Unthinkable, Prediction, Panic, and the Limits of Science. In labs and monitoring stations, the challenge unfolds. How to balance new knowledge with public safety. Improving forecasts holds the promise of saving lives. At the same time, warnings risk igniting unnecessary panic. Alaska's Veniaminoff volcano has underscored the unpredictability of volcanic warning signs. Some eruptions announce themselves weeks in advance. Others arrive with little or no warning. Even with sophisticated networks of sensors, a silent eruption remains possible. The case of Axial Seamount marks a scientific milestone. Months of advance warning have been possible only through a rare convergence of ground, ocean, and satellite monitoring. Still, scientists stress that predictions are never certain. Uncertainties remain about the scale, timing, and impacts of the coming eruption. When news of Axial Seamount's warnings surfaced, coastal communities had questions. Would an undersea eruption cause tsunamis? Would air traffic be affected? The answer? Most submarine eruptions are not tsunami generating, though minor sea level disturbances are possible. Ashfall is unlikely far inland, but deep sea vents and thermal plumes could have regional marine effects. Emergency managers monitor these threats closely, rehearsing scenarios and maintaining communication with the public. Volcanic warnings must tread a careful line, providing vital information without creating unnecessary alarm. All the while, geologists emphasize the value of community preparedness, especially near historically active peaks. The science of eruption forecasting is advancing, but each new awakening is a reminder of how much remains unknown. As researchers refine their models, The lessons of 2025 stand as both hope and caution. Progress is real, but humility before the power of the Earth remains essential.
Chapter 7. Beneath the silence, what comes next?
With the summer of 2025 underway, much of the West remains outwardly calm. Hikers ascend volcanic snowfields, and coastal life proceeds as usual, even as scientists monitor events below the surface with growing urgency. Seismic networks hum with microquakes, geothermal springs shift in temperature, and drones capture aerial views of swelling volcanic domes. Commercial pilots skirt around airspace flagged by warnings from Alaska and the Cascades. A single unexpected eruption could disrupt travel, affect water systems, and change local weather. Yet most of the region remains unchanged, for now. Official watches and advisories rise and fall as data are updated. Media attention wanes, then returns. But under forests, fields, and ocean, pressure continues to build. Steady, relentless. This tension is as important as any visible eruption. The volcanoes of the West Coast act as natural release valves, venting Earth's heat. Each awakening, minor or major, is a force that can upend local landscapes and, on occasion, global climate.
With 21 volcanoes showing increased activity and axial seamount nearing eruption, the region faces a critical moment. Will the current cycle pass with minor eruptions, or are larger events ahead? The future remains uncertain, but geological forces cannot be ignored. North America's edge is in motion. The era of deep quiet has ended. The question is not if these volcanoes will erupt again, but when. Will the West endure, marked by scars but fundamentally shaped by the fire below? Or will this current surge mark the beginning of a new era of geological change along the Pacific edge? If these questions seem weighty, it's because the signals are real, and 21 volcanoes do not show heightened activity by mere chance. Stay alert, stay informed, and encourage preparedness as Earth's story continues to unfold beneath our feet. The Ring of Fire is restless, and its secrets are only beginning to surface. Like, share, and stay tuned for the latest on America's awakening Ring of Fire, because the land below is writing its newest chapter before our eyes.